Hi, as promised, we're going to take a look at my new BK Precision 8601 DC electronic load. This is an upgrade to my 8500 electronic load. Very similar sort of beast, but this is the new whiz bang model. So thank you very much, BK Precision, for sending in this replacement model. It's very handy. Now, this new 8600 series comes in a huge range of models. This is like the second from the bottom. So this is the 120 volt, 60 amp, 250 watt model, and it's roughly equivalent to the old 8500 I've got here. It's also 120 volt but it's only 30 amps. It's a very similar look and feel between the two, but quite significant changes and upgrades on this one that I'm going to find most welcome, I'm sure. And the first one you'll see is that it's got, sorry, I turned it on before taking it apart, oops. We've got a dual line dot matrix vacuum fluorescent display, whereas before we had the pretty rudimentary 7-segment vacuum fluorescent, it's a 14-segment vacuum fluorescent display on there, and it was pretty limiting and rather annoying. So this one's much nicer. And right off the bat here, you can see we've got greater resolution. Look at this. We've got 0.1 millivolts resolution on this puppy. We only had 10 millivolts resolution before on this one. Same current resolution at 1 milliamp here. But both of them are actually capable of going down to 0.1 milliamps resolution, presumably through the serial or the comms interface. And this one's a little bit more expensive, about $1,100 US street price for this one, which is, a lot, but it's a really good DC electronic load. They are available, the iTech brand are affiliated with BK Precision, so I believe you can buy the similar unit under the iTech brand, but beware, I believe there are fake iTech brand ones on eBay. That's what I'm led to believe anyway, so just beware you're getting a genuine unit. Very similar keypad interface, but a couple of more keys. Instead, it's got the enter key here, for example, and the buttons light up. It shows you which mode you're in, constant current mode. This one didn't. Look, you boot the thing up, you don't even know what mode you're in. It's just, it's crazy. This one's much nicer, and separate shift button over here. So user interface vastly improved, which is so welcome. It's got the same excellent knob that we had before, no worries, and it's got the same big beefy binding posts on it, but as I've mentioned before, I would actually prefer to have 4mm banana jacks as well as the big binding post. That would be really nice, but yeah, it just sort of forces you to make up some custom leads if you want to hook up banana plugs to them. A little bit annoying, but big and beefy, yeah. And both of them have a temperature-controlled fan in it, but the new model is practically silent. The other one had a little bit of a hum in it. This one's even better. Nice. But of course, that's going to change once you start dissipating a fair bit of power in this thing. And you really get a lot more bang per buck on the back. Check it out. We've got a current monitor output. I believe that one's isolated. You've got a more versatile external interface here. Yes, it does remote sensing just like before, but it's got, it had the RS-232 control before. It's still got that. It's got a separate remote control as well as USB and good old GPIB as well. Whereas before you had to use the, you could get a separate optional serial to USB interface. So much nicer, but you'll notice this one has the fan on the back here. This one I can't remember. We've done a teardown of it. I think the fan's internal or something. It's got dual heat sinks either side here. So it'll be interesting to see. There could be substantial physical differences inside. In fact, there has to be. I mean, look where the main socket is. So, unless the wires go somewhere else or something like that. But yeah, anyway, I think we're going to see a complete redesign in this thing. Let's have a quick look at the data sheets between the two. I'll link them in down below for those who want to check them out. As I said, look, they come in different styles. Big, huge, beefy, rack mount things, fantastic. Although my needs don't extend that far, so the desktop unit is fantastic. The old one also did similar sort of things, and they've both got the usual modes: constant current, constant voltage, constant resistance, constant power as well. But the transient performance is much better. Apparently, it's got a new faster processor in it, so it can go up to 25 kilohertz in constant current mode for the transient, whereas before it just transient mode. Another big improvement, adjustable slew rate in constant current mode. I don't believe the original one had that. Fantastic. And you've seen me use the built-in battery test function before. I believe it's got additional capability over the old one. Fantastic. The old one was very rudimentary, although it still, I believe, only does amp hours measurement. Would have been nice to do watt hours as well. That's interesting. It's got a voltage fault pin on the output as well. Going to have a look at that one. Maybe not in this video, but... And they can operate down to fairly low voltages too, which is important. You know, you're measuring the battery discharge curve. You know, you want to go down to that, 0.8 volts for alkalines or even lower. I've gone down to, I think in some of my tests for the real low power ones, down to like 0.1 volt or well under that. But yeah, it changes with current here. They've got the various curves. It's neither here nor there over the previous one, I don't think, but this is interesting. Look, it's got an LED load mode, right? So it simulates the curve of a typical LED with a resistance region as well. I'm not entirely sure why you'd want to do it. Wouldn't you just run the actual LED and stick it in a box if you didn't want the light coming out? I don't know, but anyway, could be handy for some people. It's novel anyway. And it's got very flexible transient operation. As I said, much faster than before. You got adjustable slew rates, fantastic, and automated test modes and things like that. It's got, much more capability than the previous model on that one. And this sort of stuff is really useful for simulating products under test or measuring batteries, for example, because batteries often will do like pulse load testing and stuff like that. You can automatically switch between two loads and measure. Fantastic. And as you saw, much more versatile comms interface as well. Got GPIB, the USB, and Skippy commands. Terrific stuff. External triggering and voltage latch operation specifically for battery and other power source. You can have it switch on and off at particular levels. Fantastic. And the battery test function supposed to be more powerful. The application software looks better than the old one. So yeah, I'm keen to try that out, because that was a big gripe I had with the previous one. The supplied software, it sucked. It really did. So yeah, I hope they've improved that. Yeah, the adjustable slew rate function, anywhere from 1 milliamp per millisecond up to 2.5 amps per microsecond, depending on the model and things like that. Not sure this one can do. Look, built-in rise time measurement. This is rather fascinating. It allows you to measure rise time of power supplies, because that's one of the primary purposes of an electronic load, is to measure power supplies of not just bench power supplies, but your DC to DC converters you design and build into your products and things like that. And it can do rise and fall time measurements without having to get an oscilloscope like this. So that's rather interesting. And can just display on the screen all in the one instrument. Neat. Although, yeah, you'd want to build up confidence in that before you use it. I'd be double checking against the scope. And of course, you want the scope. You want to be able to check, you want to actually see the waveform and of course document it and things like that. But yeah, I don't know. That could be really useful for some people. And it says it can actually be used as a timer as well for timing how long you've had the thing enabled. That's great. I never really thought of that for the previous model, but yeah, I can see where that'd be handy. And the new one specifically actually has the spec for minimum input voltage 0.18 volts at 6 amps. So that's pretty good. It goes up to that 1.1 volt spec, full scale spec at 60 amps, but geez, 0.18, very nice. They haven't really changed the accuracy between it, 0.05% typical, which is absolutely superb. This thing is like a precision meter in its own right. And of course, with the remote voltage sensing as well, you can really utilize that voltage accuracy and minimize any drop and completely eliminate drop in your test leads. Now, I won't go into the specs a huge amount. You can read for yourself in the datasheet. Suffice it to say that much more stuff is specified. Transient mode and everything down here, they didn't specify any of that before. Look, that was basically all you got before. This was, these are for the different models. That's just for the one model, the 8500 there. And you can see, but this one has everything specified. Fantastic. Much better. But it doesn't end there. It actually extends onto a second page, and it does, look, the readback power, the readback current, readback voltage, the protection range, all sorts of general stuff. It's much more comprehensively spec'd. I love that. And here they are side by side, the old 8500 I've done a teardown of before, which I'll link in. Sure, it's probably comprehensive, as most of my teardowns are. This will probably be much shorter, just highlighting the differences between the two. The 8500 series and the new 8600 series, it's very similar to before. Obviously, they've shared a lot of stuff in here, and the physical differences are going to change depending on the model you select. So this one here was a 300 watt model, and they used two separate heat sinks here, a total of a total of 8 power transistors. Sorry, this one is a 250 watt model, single heatsink. It's got 10 power transistors in it. I'll show you up close very shortly. But yeah, there's lots of attention to detail in here that make this a real high quality unit. And I'll point out a couple of features. If you have a look at the old model with the binding post interface, it's just absolutely gorgeous. Everything's Loctited up. They've got specific custom bars going over to the PCB here, and very similar on the new one. Check it out, a few differences, but yeah, very nice dual nut tie down here for the bar that directly comes out from here, all custom machined, all custom made. Just gorgeous interface, exactly what you want on a real high quality, high current unit like this thing. And they've upgraded the transformer. This is the old model, and spot the difference. Here's the new model. Ta-da! Look at the extra shielding. Beauty. I'll just show you those input binding posts again and the connection to the PCB, because it's just gorgeous. Look at that. Wow. And there's our main current shunt. There's actually 4 of those in parallel, so they need that to get the power dissipation in this thing, and this fan actually sucks in, so they've got dual fan, one to suck it right through and then out the other end. But our power transistors are also tied into this heatsink as well, so it's getting rid of the power from not only the input shunt and current shunt, but the power transistors, which is actually the load. This is where all the power is dissipated. And is it good enough for 250 watts? Yeah, seems reasonable. And the main power transistors down there, genuine international rectifier, no one hung low grey market rubbish. IRFP 250Ns, and these are designed to be easily parallel connected as well, which is what they've got here. They've got 5 on each side. I won't take out the other boards to show you, but they've got 5 on one side of the heatsink, 5 on the other. Total of 10 of these things. So they're really, you know, spreading the heat around. This is real good, safe design practice to spread. And they're using big TO247 packages as well, much lower junction to case thermal resistance than your wimpy little TO220s. So yeah, really, they're doing this right. And these big wire wound resistors here, obviously the parallel sharing resistors, just to equalize the load across all the transistors. Nicely connected earth connection down there to the board as well. Look at that, and got the Loctite on it. Beauty. And you can see that the older design used some through-hole stuff. They're just op-amps, TL084s, classics. So, you know, obviously based on a much older design. And it looks like they've beefed up some of their linear regulation around here. This is the old model, and check out the new one. There it is over there. You can see that everything's got a heatsink. It's much bigger, beefier, although I got to admit I'm not a fan. This is the mains cable. It's just like running over the top of the board there. That's a real shame. Like, you know, why not route that properly? Like, they've routed, you know, they've put attention to detail and everything else. I mean, look at even the headers. They put Celastic on the headers to hold them in place, although why you wouldn't use latching ones, I'm not entirely sure. But anyway, they've gone to that effort. But that's the mains input cable, just lying on top of the board. That's like the only thing I can fault with this. You'll see that there's a fair bit more miscellaneous analog stuff all going on around here in the new design compared to the old one, which was, you know, yeah, not as much happening. And yeah, they rubbed the bloody numbers off. Urgh. And there's where the extra grunt comes from. STM32F103 ARM Cortex-M3 processor. So that one's the one that must be doing all of the calculations, because this is not an analog unit as such. It's digital. All the control happens digital. So to implement the constant power, the constant current, constant resistance, everything else, modes, it needs to do it all in software, fast DAC and ADC, and especially to do the transients and stuff like that. And the switching, that's how it's doing it in the STM processor. And there's a little Altera CPLD there, just taking care of business. Seriously, BK Precision? Nobody gives a toss what you're using for your GPIB controller. Give me a break. There's an Atmel arm to handle all the other comms interfaces, the USB and all the serial stuff. They've built a new dedicated secondary board to do all that. And check out the mains input section. Beautiful. Look at this. They've done it properly. Shake-proof washer, properly crimped and heat shrunk and everything for the earth connection. They haven't just, split it off from here. They've actually dual connected down to the one point. Of course, I'm a big fan of the power rod. Look at that. Although it does stick out the front of the case a bit too much. Not happy with that. But yeah, look, they've put Celastic on the mains power output. That's like I said, that's really my only gripe here, is that this is kind of, well, I actually pushed it across the circuitry before. I believe when I opened it was like, going over the heat sinks and everything here. But no, that should be routed better than that, down the side of the case or something. But minor. Just the mains input voltage switching. They've got MOV protection there and a nice common mode choking. It's doing the business. Nice high voltage isolation slots. Excellent. And of course, there's all your digital isolation going over to your main interface board up the top here. So all the control circuitry and everything else is at the same ground potential as the input. And there's where all the measurement magic happens. That's an Analog Devices AD7682 Pulsar ADC. 16-bit job and, yeah, pretty decent converter. You can see right next to that, there's the voltage reference. That's a Maxim 6250. Yeah, pretty common for this type of application. Good enough. And over from that, ta-da, there's our DAC. Look, good old Burr Brown, love it. Anyway, it's the DAC 8831. Once again, matching 16-bit DAC. And this particular one has, as opposed to the 8830, I think it is, has a Kelvin connection for the reference. So there's just additional connection flexibility in that chip to wire it up to eliminate connection errors or to minimize them. And no device of this quality, of course, would be complete without temperature sensing the heatsink. That's what they're doing there with that bracket. They're just holding a TO92 package temperature sensor straight onto the heatsink there. They only need to do it on one side. They don't need to do it on the other side for the power transistors, because the thermal resistance of and big aluminium heatsink like this is bugger all. You can see the other 5 matching power transistors on the other side, just tucked away in there, also with their ballast resistors as well. And I was wrong about this current monitor being isolated output. I assumed it was isolated because it was using the isolation ring around there. That's just isolating it from mains earth. But, well, it is isolated from mains earth, which is good, but it is actually connected, ta-da, down to your reference to your negative input there. So just be aware of that when you're connecting it up to a measurement system. And the display board on the front, I won't bore you with the details, very similar design and placement to the previous one. Once again, they got Celastic down here, and as I said before, not sure why they didn't use the latch-in headers in there, but you need more room for the latch-in headers, so maybe that's why they did that. But yeah, it's just going to be upgraded, its capability to drive the dual-line dot matrix vacuum fluorescent display. So there you go, there's the internals of it, just as good a quality as the previous model. Yeah, no worries, it's built to a high standard, a high quality instrument, should last a long time. Excellent, you can barely fold it. That mains wiring in there just flapping around in the breeze, that was really my only major complaint, but they really are designed and manufactured to quite a high standard, these BK Precision loads. Maybe not quite up there with, the key sites of the world, but geez, not far off. Really decent quality. And whether or not they're good bang per buck compared to the, the cheapies you can get on eBay, well, I think the performance is going to be there with these. These are spec'd much better, designed and built better, so, but they're not that cheap, but you get what you pay for. So, yeah, I think they're decent value for the money. They really are. And you get a traceable calibration certificate as well with all the measured values. Beauty. And you don't get this with it, but it's an optional TLP WR1 2-meter 60 amp test lead with spade connectors. Oh, just feel, the silicone. Oh, these leads are gorgeous. Oh, excuse me, I'm going to go in the corner and just fondle them. And I really like the setup in this thing. If you're in constant current mode, for example, you just go shift setup here and you get all the stuff. You can set your range, you can set your high threshold voltage, you can set your low, and you can set your slope rate as well. Check it out, 5 amps per microsecond. That's the up, when it rises back up to compensate, and when it falls down, you can actually set that. Beautiful. And of course, you can, when you're in constant voltage, it'll give you different settings for your different ranges. So we can go into constant power here, and there we go. There's our constant power, high, low. Nice. And battery mode's just a bit nicer to use. I'm not sure if it actually has any greater functionality. I'm just off the top of my head from last time I used it. Anyway, you can set the stop voltage like this. Hang on. Yep, you can set the stop capacity if you want it to stop. Otherwise, you just press 0 and it just ignores that. You can actually time it, have a safety timeout as well, but you can just put enter if you don't like that. And bingo, it'll show you the current power plus your accumulated amp hour capacity over here and the time you've been going. Very nice. Like I said, it would have been very nice if you could have constant power as well and get. I don't think it does. We're in constant power mode there, going to battery, and, stop capacity, stop timer, bingo, it's still in amp hours. It's not in watt hours. Would have been really nice to have a watt hour capacity as well, but you can ultimately do that in the software. You just can't do it built into the instrument. Bit of a shame, but yeah. And if you go into the configuration here, you can set various stuff, like you can set the protection, for example. Let's go and have a look. Look at maximum power, maximum current, etc., maximum time, so that you can actually just have set these things so that you can't damage your product under test. Very neat. And measurement mode, let's go in and take a look at that. Voltage range, time, filter as well. Very nice. I don't know how to go back, so I'll just cheat. There's our LED load mode, and you can switch remote sensing as well. So if we switch remote sense on, it should display that on the display. Now, should tell us, sense. There it is. Yep. And here's something I always dread, the software side of instruments, because it's always crap. The previous BK Precision software was crap, and I had high hopes for this one. And if you go into documents and software, here it is, operating software, no problems. It either includes the LabVIEW runtime engine, which presumably you need to actually run this thing, and it's got operating software, and it's got battery test software as well, either with or without the runtime engine. So you install it with the runtime engine. I installed the battery test software, and you load it up, and it looks like this. It looks better than what we had before. Okay, pretty funky. We can do a discharge test, a charge test, or a sequence test program. So you go into discharge test here, and here's the screen we get. It all looks great, okay? And I was getting nothing up here. I've connected it via the USB port, and I was getting absolutely nothing from this drop-down list here. I didn't even get the Windows thing when you plug in the USB. It just did absolutely nothing. Now, granted, if you go in here and you read this USB TMC, which is test measurement thing, installation note, then it tells you that you need to install, the EEVBlog driver. Okay, I downloaded that. It took me like an hour. It's like a 650 meg download or something. And I installed that. And I actually got, after I installed that, I did get these two drop-down boxes here with the COM one and the LPT one. LPT, parallel port, give me a break. Anyway, it's there for all the legacy stuff. It's an NI thing, National Instruments thing. Anyway, after I installed the huge, massive Visa driver, I get these, but I can't connect, either at the default 4800 or whatever. Nothing connects. I still don't get the Windows thing when I plug in the USB. Now Now, of course, this could easily be a PEBCAC error, right? Problem exists between keyboard and chair, i.e. me. But like, even a dummy like me should be able to just load the bloody software, plug in the USB, and work. And I got the existing USB to serial converter cable that came with my existing previous 8500 BK Precision load, and I'm using that. That doesn't come standard with this. It's got USB built in. You're not supposed to be able to use it. Anyway, I load that up, and it installed, sure enough, COM6. So if I connect, if I popped up, because it's just a USB serial converter, nope. So I can see the serial port, but I cannot connect to 115K board. I don't know what the baud rate is, but like, I can see the serial port, but it just ain't connecting. It's just, I hate crappy software that doesn't just work. Is it too much to ask, really? Well, it turns out you've got to go into the system menu and go into the communication settings. And by default, it was on RS232C, which I didn't see. Anyway, there's a specific setting for USB TMC. So presumably, I've got to select that before it'll even identify this thing. Okay, bingo, I'm in there. That's in the communications thing. Now, what's in the protocol? Skippy. Okay. Great, that's fine. Okay, we want Skippy commands. And so let's see now if I can connect with my damn USB. Yay! There it is. It looks like it actually enables the USB hardware inside this thing. As I said, it wouldn't even do the Windows thing when you identification when you plug it in, but now it did. Once I enabled that in the software, presumably it powered up the USB, did what circuitry, did whatever it needed to do. There it is. USB test and measurement device, IVI, ready to use. Now it's probably going to use. So is it a PEBCAC? Probably. There we go. Hey, we've got it. It looks like we might now be able to talk, but like, seriously, like, what a pain. Like, you know, just downloading the software, I don't think would have worked. I needed the National Instruments driver. I didn't even get a CD in the box. It's a 600 meg download. Like, I don't know. Anyway, connect. Here we go. Yay! We're in. Win. Like, okay, you know, it's obvious once you know, but like out of the box, just a pain in the butt. Sure, it didn't take me long to figure that out, but now this battery discharge tester, it does look like it is better, more functional than the other one, but still it doesn't have basic functionality like constant power discharge to get watt hours. Look, discharge, you can either set the discharge current or the discharge C rate, but you know, either way, you can set your discharge current. So, you know, 0.1 amps, 100 milliamps or whatever. And what if you want watt hours? It's just, no, come on, you know, it's not comprehensive enough. It's okay if you just, you know, it's great if you just want amp hours, but if you want watt hours, which is the true measure of battery capacity, then, well, it doesn't cut the mustard. You'd have to do it manually. I'm going to set up like a 50 milliamp discharge here. I've got a little CR2032 battery hooked up. I think it's new. And I'm just going to, like, that's way over its capability, 50 milliamps. Shouldn't discharge it at that. But anyway, I just thought I'd try it. So let's give that a whirl. So I can set the dropout voltage to, say, you know, 2.6 volts or something like that. So let's give that a whirl and start, presumably. Let's go. Is it starting? You can switch on and off the remote sense as well. Switch that off. Hello, I press start. I'd expect data to start automatically appearing on the graph and be automatically... Nah, let me go check the unit. Alright, it looks like it had down here, for the interval it had by default 0. So I'm going to set it to 1 second. And let's see what happens if we set it to 1 second interval. Start. No. Okay, so let's just try that again. I've restarted everything and, well, when in doubt, have you tried turning it off and on? So let's start and bingo. Something's happening. Yet the voltage dropped right back, right down, of course, immediately. There you go. It's dropped down to 2.3. So I didn't set the threshold this time because it would have just cut off instantly there before it got to the first second. So, well, was that the problem? I don't know. Anyway, there you go. We're getting our battery discharge curve. So, yeah, it's working. Okay, no worries. Yeah, as I said, it's a bit, from memory, it's a lot better looking than the previous software, but it still has the same limitations and things like that. And I can export the data. Can I export the data? There we go. I can export to clipboard. No worries. But the auto scale, like X, doesn't work on this one. Like it's just broken. Like why? You know, it's just dumb. I don't know what's, you know, there's no, stupid. Not happy. Okay, it's got various, these various measurement things and stuff like that. Okay, can we zoom into that? There we go. Oh, no, it just reset back. Yep, capacity. Why has it got a maximum capacity of 0.1 amp hours? I don't know. Did we set that anywhere? No, we didn't set that. It should have. Like, why doesn't Auto X scale work? I don't know. It's just, yeah, still a little bit clunky. But it works. There it is. All right, let's install just the generic 8600 software. I don't know what it does, but it's only 6 meg download, by the way, if you don't get the runtime stuff with it, which is quite nice. So let me run this again. Sorry, it's on my other screen. I'm not capturing that. Adds it to my B. Here we go. MDL. It's loading up. Windows has blocked it. Here we go. Boom. MDL series, 8600 series. That's what we want. Demo. No. I want to connect. Here we go. Can we connect? Here we go. Yep, we can. Connect. Bingo, voltage. There we go. We can see my battery connected to it. No worries. Okay, great. Waveform recording. All right. Transient operation. That's all right. There we go. Transient constant current, constant power, constant voltage, constant resistance. That's all right. All right. So the main software is a bit better, but you're basically just operating it remotely. You know, you can do all this stuff on the front panel, except a waveform recording, of course. So it looks like, yep, you can start everything else. You can start and stop, which is fine. Input off or on. Short off or on. Remote sense off or on. Okay, we've got our virtual knob there. Enable overcurrent protection, blah, blah, blah. Hardware power limit, blah, blah, blah. So, yeah, okay. And it's still... It's a bit dicky. Anyway, look, we can save a list. No, that's a program list. Okay, but once again, like waveform recording. Okay, we can get this waveform. Okay, but how do we, like, you can't extract it. How do you save it? I can't see it. Right? Crazy. Okay, so here we go. I'm in constant current mode. I've set it to 10 milliamps down here. Type that in, and I can turn my input off or on. Okay, you can see I've already tested it. The battery voltage is increasing back up here because I loaded it down with 10 milliamps, which is quite a substantial load for a CR2032 battery. And if I load it down, you can instantly see it drops down to 2.7 volts. This is probably not a brand new freshie. And, well, yeah, whoop-de-doo. Waveform recording. Start. Here we go. And maybe we can just see it drop. There we go. Starting to get a few wiggles in there. We can start to drop. Okay. That's not as exciting as it was before. So what I'll do is I'll go back to here. So you can operate different parts of those. So let it go back up. Okay. And if we go down to here, waveform recording, I assume it clears the window. Export data to clipboard. Export data to Excel. Okay. Export simplified image. So like oh, come on, PNG. Give me a bitmap and EPS. Enhanced meta file. Come on. Jeez, just a PNG. Thank you very much. Anyway, if we if we just go start. So let's clear the chart. and then we start recording, okay? So there's our battery voltage, and if we just... Oh, no, we can't go back over. See, we can't go back over. So how do I supposed to... Now I've got to run over and switch the thing on. I had to hit the local button on there. Here we go. I did hit the local button, and it's still doing it. So it's annoying. Now you want to start recording and then switch the damn input on. Like, that's just... It's crazy. This software is so clunky. And here's what happens if I right-click on there and export data, or copy the data to the clipboard and then paste it into Notepad. It's giving me the tabular-based stuff like that, so that's all right. Don't save. I can't export data to Excel. Maybe after I stop I can. So there we go, stop, but I still haven't stopped my input. I don't want to go back to the main screen. Look, why can't I export my data to Excel? That's just ridiculous. Export data to clipboard. So if I call up my spreadsheet and I paste that data in, here we go. I can paste it. It's automatically, tab. It's automatically detected that it's tabbed. Okay, I can paste it into Excel. That's fine. Okay, but anyway, clunky software. I don't want to test anything else. I'm done on the software. It's just jazzed up a bit prettier than before. Hardware, I really like. Really nice electronic load if you're after one, but, don't expect the software to do much. But the whole idea, I guess, is that, they do have a programming guide which comes with this thing. If you go over here to the manual, where is it? They've got the programming manual here, so you can download that, and it tells you, all the Skippy commands and everything else. So it's fully documented. So if you want to write your own software, which isn't hard, of course, it's got LabVIEW drivers and everything else, so you can really put together programs, pretty quickly. So it's really super flexible, so that's great. Look at that, no worries. That's excellent. Okay, so what I'm going to do now is just do a simple transient operation, constant current transient, nothing fancy at all. I like, fancy-pantsy constant power. I'm going to switch between, say, 2 amps here and 0.2 amps here. And just 1 second, I don't know, just default 1 second. Intervals between them, and trigger to start. Bingo, there we go, 60 watts down to 0. Boom, every second, it's doing the business. Beauty, and it looks like we can start and log this at the same time. So we can start logging that. So we turn off input, and now I've got it sequencing between 2 amps and 0.2 amps. I like how it tells you the number of transitions up here. That's very nice. But what I've actually done is gone in there, and can I disable this? Local constant, local off. It's all right, I've already captured it. Local, hello, McFly, shift, setup, and I've gone in there and actually changed the slew rate. I've gone to the low rate, and I've actually changed it to 0.01 amps per millisecond, so 10 milliamps per millisecond. Slope time for Ryzen 4, but I thought this would work when you press the on-off button, just manually on the thing, but it doesn't. It still does it instantly when you go off-on. It looks like the Ryzen 4 time. I stand to be corrected if there's an option to do it, but it only works in that sequence programming mode we were just doing, and that's a bit disappointing. I would have liked to just do the button, but anyway, if we go up here and have a look at our waveform, there we go. You can see I captured that, and you can see that it actually ramps over that time there. There we go, 100. It takes 200 milliseconds there to actually do the rise and fall. So that's exactly what you'd expect, 200 milliseconds, if what we've done is programmed it to be 10 milliamps per millisecond. So yeah, it's bang on, it works, but as I said, only in that sequencing mode, not with the on-off. So there you go. That's a look at the new BK Precision 8601 electronic load, and it's a decent step up from my old 8500 model. I really like it. There's some extra flexibility, extra resolution, much more faster operation. Haven't real performance tested in terms of, its faster transition times and all that sort of stuff, but it looks like it has some quite useful extra functionality, and before you had to buy the previous USB cable, now it's all built in. But yeah, as always, included software is a bit, it leaves a bit to be desired. I'm not going to write home about it, but ultimately it does work, and you can make it do most things that are required. But ultimately, a lot of the applications that this load is going to be used for are going to be custom applications, custom development. So, really easy to write your own software to actually drive this thing and do precisely what you want, because the hardware is capable of doing an awful lot, which the software doesn't look like it can take complete advantage of it. For example, constant power mode for battery tests. So if you're really doing comprehensive battery testing, the included application might not be enough, but it's enough to maybe get you up and running. But a lot of people are just going to write their own software, so that's all hunky-dory, it's all documented, and it's a really great, well-built supply. So I think it's decent value for money if you're after a good quality supply. Load. It's an electronic load, not a supply. So there you go. It's really quite nice. I like it. Thank you very much, BK Precision. Links will be down below. As always, high-res teardown photos at EEVBlog.com. They'll be linked down below as well. And after this, I'll link in some videos, some other videos I've done on things like this that you might want to watch. Catch you next time. What's needed is an electronic load that you can just dial up whatever load you need to test out your power supply. And I thought it's about time I probably built one. So I thought I would get some junk box components, see what I had lying around, and lash one up. And here's the result. Let's go through it. So, what's needed for a simple electronic load? Well, basically an electronic load is just a constant current sink